Hello, boys and girls. This is Mr. Newman, and today we are going to grade Weekly Review 2.5. 2.5. So make sure that you have the right weekly review out. Normally, we grade this on Monday, but since you will not be here on Monday, I want to go ahead and grade it now. So you should have already submitted this in Canvas. If you've not submitted this, you need to go back and submit this in Canvas before you grade it. All right. Now remember, if you ever have any questions or you see any mistakes, please let me know. Please let me know. Remember, this is Weekly Review 2.5. All right, number one, what is the sum of 35,982 plus 48,254? Now, sum means the answer to an addition problem. So what is the answer to this addition problem? What is the sum? You should know what that word means. So I'm going to use the standard algorithm of addition, and I'm just going to stack these numbers and add them up. It doesn't matter the order you stack them in. You could stack them in any order. Normally, whatever number has more digits, I like to put that on the top. But since these all have the same amount of digits, they're both 5-digit numbers, it doesn't really matter the order you stack them in. All right, start with the ones place. Let's add the ones place first. 4 plus 2 is 6. And in the tens place, 8 plus 5. Remember, it's 80 plus 50, but we're going to write it in the tens place. 8 plus 5 is 13. 13 tens would be 130. And then hundreds place, we have 900 plus 200 plus one more. These two, I definitely want to add these two together first because I can make 10. Anytime I can make 10, I want to do that because it's easy to add to 10. So I want to chunk these together first. 9 and 1 make 10, plus 2 is 12. That's 12 hundreds, which is 1,200. All right, on to the thousands place. 1 and 5 make 6, plus 8 is 14. That's 14 thousands. And the 10,000s place. 3 and 1 make 4, plus 4 is 8, 80,000. So 84,236 is my sum. That is my sum. All right, on to number 2. Select all of the inequalities. Inequalities means all the problems that are not true, or excuse me, not equal. The word in means not, and then you see equality there, so not equal. All of the inequalities that are true. So two numbers that are not equal. All right, select all that are true. So let's look at A, and I just look at my largest place values first. Both of these have, let's see, 6 digits, so that's good. Start with the 100,000s place. 7, 7, and then those are the same, so that really can't help me with my answer, so I'm just going to cross those out. And then I move to the 10,000s place. This is 20,000. This is 40,000. So, and the sign is a less than sign, so that is true. This is a true statement. So move on to the next one. It says all, so there's probably going to be more than one answer here. On to B, same thing, 6-digit number, 6-digit number. We have 100,000, 100,000. That doesn't help me with my answer. On to the 10,000s place. We have 80,000, we have 90,000. So this sign should be going that way. So that is not true. Remember, I'm circling the ones that are true. On to C, 6-digit number, 6-digit number. 100,000s place is both the same, so we can cross that out. Look at the 10,000s place. This is 80,000. This is 60,000. 80,000 is definitely larger, so that should be a greater than sign. That is not true. On to letter D. 6-digit number, 6-digit number, so that's good. Look at the 100,000s place. 800,000, 800,000, so I can't find my answer there. On to the 10,000s place. 40,000, 40,000. Can't find my answer there. To the thousands place. This is 3,000. That's 2,000. Well, 3,000 is greater than 2,000. So, yes, that is true. So, A and D are the correct answers for number 2. All right, number 3. It says Zach solved the following problem. Is he correct or incorrect? What error did he make, if any? So we have to say if he's correct or incorrect, what error did he make? Let's go ahead and just solve this. I'm going to zoom in a little bit, and let's figure it out. So start with the ones place and just subtract and see if he made any errors. 9 minus 2 is 7, so that's good. And then let's move on to the tens place. I can't take 8 from nothing, so I have to do some regrouping here. That would be 0, and then I have to give this 10. So I have to take away 100. That's 10. 10 tens is 100. So I subtract, and 10 tens minus 8 tens is 2 tens. So he put 8 tens. So it looks like he did not regroup. So he's definitely incorrect. He's incorrect. And then why? Why? He didn't regroup in the tens place. He can't take 880 from no value at all, so he did not regroup. I'm just going to say why he did not regroup correctly in the tens place. There we go. And you could, there's a lot of different ways you can write that, but you definitely need to say he's incorrect and say why. He did not regroup correctly in the tens place, so his answer is wrong. You can you can just do that problem again and just see if you get the same answer. And okay, where did he make a mistake? And it's obviously right there, which it's a common mistake. I see it a lot in 4th grade, but he definitely did not regroup correctly because you should get a 2 in the tens place, not an 8. All right, on to number 4. Marcia and Jack were asked by Miss Ellis to find the product. That means to multiply. 37 times 43. Each wrote a strategy on the paper and showed it to Miss Ellis. Here's Marcia's strategy. It looks like she used the distributive property. And here's Jack's strategy. And it looks like he also used the distributive property. So you could always work these out and see if you get the same answer. But if you stack this problem up, I'm just going to go ahead and do that. 37 times 43. And you did partial products to solve this. You would have to say 3 times 7. So we have that here. And then 3 times 30. We have that here. And then the 3 has been multiplied by the 7 by the 3. So you can kind of cross that out if you want because you've used it. And then you move over to the 40. 40 times 7. Let's see. 40 times 7 is right there. And then 40 times 30, which is right there. So Marcia's definitely correct. Let's see if Jack's correct. So Jack is doing 30 times 43. 30 times 43. So that's kind of like this step right here. I'm just going to put like a box around it. This step, 30 times 43, and then 30 times 3. That's like these two steps together at one time. And you could definitely do that. I mean, if you add 40 plus 3, that is the same thing as 30 times 43. That is these two answers just in one, like one chunk. If you're good at multiplication, you could definitely do that. And then 7 times 43, well, we have 7 times 40, then 7 times 3. That is these two in one chunk. And you could definitely do that as well. That is 7 times 43. And if you do both of these and then add them together, it's like doing this right here. It's just making it shorter. It's doing it in fewer steps. Here, Marcia, it looks like Marcia used 4 partial products, and Jack only used 2 partial products. That is perfectly okay. Jack would get done with this problem a little sooner. I think it's definitely a little harder to do it this way, but if you're good at multiplication, you could definitely save some time by doing it in 2 partial products instead of 4. So the correct answer here is they are both correct. You will both get the right answer if you solve it, if you multiply correctly. All right, on to number 5. Christina received 350 pieces of candy while trick-or-treating. She wants to give them equally to her 3 sisters. How many pieces of candy will each sister receive? So that is 350 divided by 3 equals We'll just say C for candy. All right, I'm just going to go down here and solve it where I have some room. You can always do this on scrap paper if you would like. I'm just going to solve it right here. What method am I going to use? Well, I've showed you 4 strategies of division. I'm going to use number bond. That's what I'm going to use, a number bond. 350, and then I'm going to break that up into, let's see here. What is a good bond here? I'm trying to think of my multiples of 50 or multiples of 3. I'm going to do 300. 300. That's easy. That's just 3 times 100. So I'm going to go ahead and work that out. 300 divided by, remember we're dividing everything by 3. So that just equals 100. So that is my first quotient. But I'm going to have another one because I got to go all the way to 350. Now I'm not going to use 50 next because I would like to, but 50 is not a multiple of 3. So I can't use 50. I'm going to think of another number that's very close. I'm just going to use 30. That's easy. That would just be 30 divided by 3, which is 10. Now remember, I have to go back to 350. Right now I'm at 330. I've got 20 more. I've got 20 more to do, but 20 is not a multiple of 3, but 18 is. 18 is. 18 divided by 3 would be 6. I'm almost there. Right now, I'm at 348. I've got 2 more to go, and 3 can't go into 2, so that's why I'm going to put this little square here and just put a 2 in there. Make that a little neater. A little bigger box so you guys can see it. There, put a 2 in there, and this is the remainder. This is the part that 3 cannot fit into equally. So my partial quotients here, my parts of the answer are 100, 10, and 6. Well, if you add these up, that's 116, remainder 2. But the remainder 2 here, this is a word problem, and I say you have to use the remainder. So we cannot say each person can get 116 pieces remainder 2. That's not true. The remainder 2 cannot be equally split between 3 girls, so they can just get C equals 116 pieces of candy. That's it. So this is a question where you just have to, you can't use the remainder. You can't use it because you have 3 girls, only 2 pieces left. You can't give everyone another piece, so the remainder will not be used here. All right? And if you use a different strategy, that's fine. That's perfectly okay. You might have used a standard algorithm or an area model or place value disk. That's fine. All right, I'm going to get rid of this so I got some more room. There we go. All right, on to, what number are we on now? Number 6. Hannah is paid $8 an hour for babysitting her siblings. Louisa is paid twice as much as Hannah. Logan's paid 4 times less money than Louisa. How much money is Logan paid per hour for babysitting? So this is a problem where I like to make just a simple chart. We have Hannah. Zoom in just a little bit on this problem. So we have Hannah. We have Louisa. And we have, and I guess, so we got 2 L's, so I got to say L-O-U-I-S-A, Louisa, and we have Logan, L-O-G-A-N. Because we have a lot of information we just have to organize. So I'm just making a simple chart here. So Hannah's paid $8, so I'm just going to put that in there. And then Louisa's paid twice as much as Hannah, so let's go ahead and figure that out. Twice as much as 8 is $16, okay? And then it says Logan's paid 4 times less. 4 times less means you have to divide by 4, not multiply, because it says less, not 4 times more, 4 times less. That means you got to divide by 4. So Logan's paid 4 times less money than Louisa. We have to take 16 and divide it by 4, which is 16 divided by 4. You can do that, which is just $4. So there you go. Logan's paid $4 for babysitting. So if you're looking for a babysitter, you need to hire Logan because that's the best deal. All right, number 7. We've already worked this problem together. We've already worked it, so I'm not going to work it again. You just need to go back to your, I believe it was Wednesday's video. I worked this problem with you. So to save some time, I'm not going to work it again. Number 8, select all the numbers that are multiples of 20. Well, if you look right here, multiples, remember multiples means many. You have to multiply. So multiples of 20, for example, 20 times 1, 20 times 2, 20 times 3, 20 times 4, 80. Guys, this is a typo. None of these are multiples of 20. None of them are. And maybe if you put zeros on these, then you would have these two would be multiples of 20. But this is a typo. I'm pretty sure this is supposed to say, I read the problem wrong. I'm sorry. It says select all the numbers that are multiples of 20 and 36. So, and then multiples, they have to get bigger. You have to multiply. You skip count by that number. So this is definitely a typo. Hopefully you figured that out. This should definitely say factors. Factors. I should have fixed that before I sent this out to you. But it should say factors. So I'm just going to do a T-chart real quick of factors of 20 and then factors of 36. All right, factors of 20 are 1 and 20. We have 2 times 10. 3 doesn't work. 4 does. 4 times 5, and then I get back to 5. That's all the factors of 20. There are 6 factors of 20. Factors of 36, there's a lot more of these. We have 1 and 36. We have 2 and 18. We have 3 and 12. We have 4 times 9. 5 doesn't work. 6 does. 6 times 6. And then we get back to this row again. So that's all of them. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't want to count 6 twice. So I actually have 9 factors of 36. Which ones do we have in common? Well, 1 is in common, and 1 will be in common of all numbers, so usually that's not even a choice, and it's not. What else do we have in common? We have 2 in common, because they're both even numbers. Yep, there we go, 2. What else is in common? 4. We both have 4. Is 4 a choice? Yes, 4. 3 is in this list, but not in 20, so not 3. And 5 only works with numbers that end in 0 or 5, so 36. 5 won't work for 36. So the 2 common factors between 20 and 36 are 4 and 2. And that is the end of the first page. I know it took a minute, but there's a lot of good problems here. So note your mistakes, learn from your mistakes, and on to page 2 we go. Okay, page 2. Of the weekly review. Now this comes from, if you notice, look at the top when you get to these type of pages, this comes from lesson 12, or excuse me, lesson 11 in Zern. So most of you guys have done lesson 11 in Zern. So you've done problems like this before. Make sure you read the directions. It says solve the following expressions. These are expressions, not equations, using the standard algorithm, partial products method, and area models. So we're going to do that. First thing, the area model is drawn for us. So let's go ahead and put our area model up there. 302 times 8. So 300 and then 2. And I'm going to put 8 here on the side. So 300 plus 2 is 302 times 8. Inside these boxes, 8 times 300 would be 2,400, 2,400. And then 8 times 2 is 16. And same thing here. 8 times 300. And then 8 times 2. This is the distributive property right here. Same thing. All right, let's just use the standard algorithm real quick. As soon as I add these up here, these will be my partial products, so that covers this method. So 2,400 plus 16. These are your partial products. Notice I only have 2 partial products because I just have 8 times 2 and then 8 times 300. And then the standard algorithm. So the standard algorithm, you guys know how to do that. Times 8. 8 times 2 is 16. I got to regroup there. 8 times 0. 0 plus 1 is 1. 8 times 3 is 24. I don't need to regroup because I don't have any more numbers to regroup over. So I just put it down here. 24, which is 2400s. And then 2,416. Standard algorithm, let's go ahead and add this up. 1, 4, 2, same answer, and then here is your area model. So we have standard algorithm, partial products, area model. Got everything, okay? B, same thing. Now we have three digits here, 3 digits, and they all have values, so that's why this box is cut into 3 instead of 2. When you go back to this one, you'll notice it is a 3-digit number, but the tens place doesn't have any value, so that's why this is only cut up into 2 instead of 3. This one, all the digits have values, so that's why we have 3. So I'm going to take this number, break it apart. 200 plus 10 plus 6, 216, and then times 5. Okay? And I'll do the partial products over here. 5 times 200 is 1,000. 5 times 2 is 10, and then 1, 2 zeros. 5 times 10 is 50, and then 5 times 6 is 30. So there's your partial products. Go ahead and fill this in. So 5 times 200 plus 5 times 10 plus 5 times 6. And then here's the distributive property here. 5 times 200, 5 times 10, 5 times 6. And that's exactly, these are our answers right here for the distributive property. So 5 times 200 is there, 5 times 50 is there, 5 times 30 is there. All right, and lastly, the standard algorithm. My 2's are looking like Z's. Sorry. 216 times 5. 5 times 6 is 30. I regroup in this method, remember. 5 times 1 is 5, plus 3. Remember, we add what's on top. We don't multiply. That is 8. And then 5 times 2 is 10. So 1,080. Let's do this to make sure we get the same answer. Yes, we do. And, yep, that's all we need to do, really. So partial products, standard algorithm, area model. You can put your answers inside here, too, if you want. You can do this if you'd like. I just saved some time. I did not do this. But you're more than welcome to put your answers inside. This is the area. This is where you write area anyways. Remember, this is what it covers. So this covers 1,000 square units. This covers 50 square units. This covers 30 square units. All right, last one. You guys get the hang of this? So 593, that would be 500 plus 90 plus 3 times 9. So we have 9 on the outside. Remember, they've already done this for you, but you can do it. 9, and that's going to be times. Anytime a number is outside parentheses like that, you have to multiply the 9 to every number inside parentheses. So this is something you'll do a lot in 5th grade when you do the order of operations. But anytime a number is next to parentheses, you multiply that number, what's inside the parentheses. So 9 times 500. 9 times 90, and then 9 times 3. Then I'm going to write all this out. 9 times 500, 9 times 90, and then 9 times 3. This is the distributive property. All right, partial products. So 500 times 9. 5 times 9 is 45. Then I have 2 zeros, so it's 4,500, 4,500. 9 times 90. Well, 9 times 9 is 81, and it has 1 zero, so that'll be 810. 810. And then 9 times 3 is just 27. No zeros to add, so there's my partial products. I have 3 partial products. I have 3 boxes. Standard algorithm, 593 times 9. Remember, we have to regroup in this method, okay? 9 times 3 is 27. 9 times 9 is 81, 82, 83. So 83. And then 9 times 5 is 45, plus 8 would be 53. So 5,337. Let's make sure that's correct. Let's go do this. This is the partial products. This is what I get inside these boxes here as the area. So 7 in the 1's place, 3 in the 10's place. 8 plus 5 is 13. That would be 1300s. I regroup 5. All right, same answer. Cool. So standard algorithm, partial products, area model. Page 2 done. All right, page 3 and 4, we're just going to do these together. I don't think these take too long. This week we talked about number bonds, so this should be familiar to you now. Let's change the color. Let's do purple. Last 2 pages. Here we go. Maria solved the division problem below by drawing an area model. Here's our area model. Okay. She's already split up her dividend. Notice that these are the numbers that she started with. She's dividing by 3, and these are her quotients. Remember how to do this? So look at the area model. What division problem did Maria solve? So if I have to get back to the original problem, remember, this is how she split it up. She split up these into easy multiples of 3. So if I put the problem back together, it originally looked like this. 30 plus 24 would be 54. So is 54 divided by 3 equals, well, back then we didn't know the answer, so I'll just put C. So if I write the problem like an equation, it would be 54 divided by 3. Okay, and that is an expression. If you want to write it like that, that's fine. Or you can write it like an equation. You just have to put your equal sign and give it a variable. Okay, 54 divided by 3. That's the problem she's trying to solve. I just had to work backwards to figure out, okay, what problem did she try to do? And we know the answer. You can actually write the answer. You can say 54 divided by 3 equals 18. Because here's the answer right here. 10 plus 8. All right, now it says show a number bond to represent Maria's area problem or area model. Start with the total, then split it up into 2 parts. I'm just going to split it up like she did. So I'm going to start with the total. The total is 54. It's right here, 30 plus 24. This is the total. And she broke it up into 30 plus 24. Those are great numbers because both of these are easy multiples of 3. Watch this. 30 divided by 3, and that's 30 divided by 3, that's easy, that's 10. And then 24 divided by 3, and that's easy, that is 8. And then you add 10 plus 8 is 18. That is one of our division strategies. Very easy, very easy. But Maria was very good. She was very good about what she broke this number up to. She broke it up to 30 and 24. Why did she do that? Because it's easy to divide 30 divided by 3 and 24 divided by 3. You know, she could have broke it up, let's say, what if she did this? She did, like, for example, 50 and 4. Now, that would not make sense to break it up like this because 3 does not go into 50 evenly, and 3 cannot fit into 4 evenly. Neither one of these are multiples of 3, so it would not make sense to break the problem. You did not make the problem any easier. Maria knows that, and that's why she broke it up wisely, and that's what I want you guys to get better at. How should you break the problem up? So this is not a good option. All right, on to number 2. It says solve 42 divided by 3 using an area model, draw a number bond, and use a distributive property to show the unknown. So we got 3 things to do: an area model, number bond, distributive property. All of these things you should be familiar with. This one right here, very easy. You probably do the distributive property, you just don't realize you're doing it. So I'll show you what this is, just in case you're confused about the distributive property. It's very easy. And we can actually do this first. It's very, very easy. We just take our dividend and we divide each value of 42 by 3. So I'll show you. 40 divided by 3. Okay, 40 divided by 3. And actually, let's break the problem up first, because if we do it that way, then 2 divided by 3, that's not going to work. So let's break the problem up first. Let's do the area model. So let's go ahead and write an equation. 42 divided by 3 equals, we'll say, n. Don't know the answer yet, so I'm going to start with the area model here. Divided by 3, and what should I break this problem up to? What should I break it up to? So think of what is your largest multiple of 3 that you know without going over 42? I'm just going to do 30. That's easy. 3 times 10, and then what's left over would be 12. That's super easy. I can easily figure out 30 divided by 3 and 12 divided by 3. That's what's going to go on the top here. So let me erase that in and go ahead and just put the answer in there. So 30 divided by 3 is 10. 12 divided by 3 is 4. Let's do a number bond now. Here's a number bond. We started with 42, and then I broke this down into 30 and 12. I broke it down that way because these are both multiples of 3. I'll show you. 30 divided by 3 would just evenly be 10. And then 12 divided by 3 would easily be 4. There you go, and just add these up. 10 plus 4 is 14 as my quotient. Same thing here, 10 plus 4, 14 is my quotient. Distributive property. So here's the distributive property. We're going to do 30 divided by 3, okay, plus 12 divided by 3. That's the distributive property, and that would just be 10 plus 4, and that would be 14. There you go. So distributive property, check. Number bond, check. Area model, check. Okay? So it was definitely a good idea to do this last, not first. All right? Any questions? Let me know. All right, and the last two problems. Solve 60 divided by 4 using an area model. Draw a number bond to show how you partition the area, and then represent division with a written method. All right, here we go. So let's use an area model. So we're doing 60 divided by 4 equals a number C. How should we break this up? Well, let's figure it out. I'm going to do 40. That's pretty easy. 40 and what's left over? 20. Is 20 a multiple of 4? Yes, it is. So I'm going to do 40 and 20. 4 times 10. 4 times 10 is 40, or you could say 40 divided by 4 is 10. 4 times 5 is 20. So that works out very nicely. The number bond would look like this, 60, and I broke that down into 40. 40, that's not a good 40. 40 plus 20, and then I have to divide each of those by 4. 40 divided by 4 is 10. 20 divided by 4 is 5. You add those up to get 15. You add these up to get 15. There we go. So what's the answer? It's 15. So let's write an equation here. 60 divided by 40 equals 15. Ta-da! Easy. Hope you get the hang of this. And it works really good, especially when you have a 2-digit dividend. 2 digits. I love the number bond or area model. Works great. All right, number 4 and 5. Oh, we had 3 problems. I'm sorry. 3 problems left. So now just 2 problems. Solve 72 divided by 4 using an area model. Explain using words, pictures, numbers, the connection of the distributive property to the area model. So it says or, so you don't have to do all of these, but I am going to use an area model, okay? So I'm doing 72 as my original area divided by 4 equals, we'll say R. How should I break this number up? Well, let's figure it out. I always like to use tens if I can. Let's do 40. Let's break it up into 40. How much do I have left to get back to 72? I have 32 left. Is 32 a multiple of 4? Yes, it is. So that's going to work out beautifully. 4 times 10 is 40. 4 times 8 is 32. So it looks like R is going to be equal to 18. Just add up your 2 partial quotients. Remember, this is called your quotient. These are parts of the quotient. Add them up to get your final quotient. Okay? Distributive property, we can definitely use that. So we broke our problem up into 40 divided by 4. Okay? Plus 32 divided by 4. And that equals 10, and this equals 8. Add these up to get 18. All right. And you can explain using words. You can draw, it says pictures, so you can do a place value dis if you want to do that. That would work awesome. But as long as you did an area model, you're good to go. Okay. Number 6, solve using an area model and the standard algorithm. So this is where the only question we got so far that says definitely use the standard algorithm. So I'm excited to use this. Area model, let's do that first. So we have 96 divided by 6. Let's fix that. 6 equals, we'll say, W. All right, I don't know how many times 6 can go to 96, even if it works evenly, not really sure, but I'm going to break this number up. Let's break it up. Can I use 60? Let's see if I can. So we have 6. I'm going to use 60 because, like I said, I like using zeros when I can. So that's just 60 divided by 6 is 10. What's left over to get to 96? So that'd be 36. Is 36 a multiple of 6? Yes, it is. 6 times 6. So I'm going to use 60 and 36. Always check to make sure these two numbers or three numbers, however many numbers you use, gets you back to 96. So 60 plus 36 is 96. So these area models are the same thing. Make sure you realize that. They're the same exact thing. They're just broken up into two parts instead of one part. 6 times 10 is 60. 6 times 6 is 36. And there's W right there. 10 plus 6. W equals 16. Standard algorithm. Let's go do that. 96. And then we write this division bar, 96 divided by 6. Remember, standard algorithm is the divide, multiply, subtract, bring down. So how many times can 6 go into our first digit here, my largest digit? 9. And I'm going to put these blanks up here, blank, blank, because I have a 2-digit dividend. I'm going to put 2 blanks up here. Can 6 go into 9? Yes, it can go into 9 one time. So I put a 1. So I just divided. Now I multiply. 1 times 6 is 6. I write that underneath the 9, and I subtract. 9 minus 6 is 3. Is 3 less than 6? Yes, so you picked a good number. Now we just subtracted, so that's the S. Now we bring down. We bring down the 6 next to the 3 that we subtracted. Now we have a new problem, 36 divided by 6. So the problem is moved down here now. 36 divided by 6. That's easy. That's 6. 6 can go into 36 6 times, and we multiply. We just divided 6 into 36. Now we multiply. 6 times 6 is 36. Now we subtract. We get 0. Awesome. Now we bring down. Look, nothing else to bring down, and you filled in all your digits, so you are finished. Here's your quotient right here at the top, 16. W equals 16. Standard algorithm. All right, guys. That's it. I know this took a while, but a lot of good problems. Note your mistakes. Let me know how many you missed, and have an awesome, awesome Thanksgiving holiday. See you. Bye.